In my last video, I went over an example where a box was stationary on an incline and showed that the friction force is equal to the component of the box's weight that acts in the direction parallel to the incline. But what about a scenario where the friction force is not great enough to keep the box stationary? If we use this same example but say that the friction force is now only 8 newtons, we know that the box will accelerate down the incline due to a net force. By subtracting the friction force from the component of the weight that acts down the incline, we find that the net force is 6.72 newtons. Using Newton's second law, we know that this net force is equal to the box's mass multiplied by its acceleration. And solving for this acceleration, we find that it's equal to 2.24 meters per second squared. With the information that we have, we can also solve for the coefficient of friction. Note that in this problem, it's the kinetic coefficient of friction that we're solving for, since the box is no longer stationary. Just like in the last problem, the force due to friction is equal to the coefficient of friction multiplied by the normal force. The normal force is also unchanged from the last problem, since it's only dependent on the box's weight and the angle of the incline. Plugging in the information that we know, we find that the kinetic coefficient of friction is equal to 0.31. Alternatively, this problem could have been set up in a way where the kinetic coefficient of friction was given and the friction force was not. If that was the case, you would need to work backwards, first finding the friction force, which would allow you to find the net force, which would ultimately allow you to solve for the acceleration. I hope that this video was helpful, and as always, be sure to comment below if anything was unclear. Thanks for watching.